let's begin. Alright, where did we stop last week? If I remember correctly, see, I think we finished all the programs. Ah, okay, recursion, I remember. So we stopped somewhere with recursion. Mm, recursive function. Alright, so we discussed a little bit, remember, how recursion works. So, um, yeah, I hope you guys also did your part and do some research about it because it's quite confusing, really. It takes about a few tries of different problems before you can actually figure out how it works. Okay, but once you figure it out, it's quite easy. And um, although it's very efficient, it's an elegant solution. It's not always like you can come up with it directly um, in that instant while you're solving it. It's very complex actually to think of solution in recursive uh, recursive format. All right. Defining a recursive. I think we were done this part. Let's see. Um, margin, double margin. I think this is a good example, and then we can just um, use those. Okay, so we have a function here. They define the summation, right? And then I think there's something similar here. Oh no, it's just the display range. So what we have here is that it has parameters, lower, upper, and margin, right? So the summation here is similar to what the summation did before in our previous examples, right? It just adds all the numbers from upper up until from lower up until upper. And then the margin here is the spacing that you see in these locations to visualize much more easily what happens with recursion. All right, so let's get back here. Now mm, let's see, the program is quite simple. We just need to make a function that uh, has a number that keeps on storing the sum, right? Has a variable that keeps on storing the sum, and then um, another number that keeps on increasing and keeps on adding to that sum up until a certain limit is reached, right? All we have to do is convert that logic into um, into code, and that's it. Oh, also we'll make it into a recursive fashion. So in the beginning, these are just blanks. So we have here blank times margin. So what you have if you do something like this is you will get like these spaces afterwards. Okay, so at the beginning, um, margin would be equal to, let's see, they're calling margin here at 0. So basically there's no spacing, right? Let's try that one out. Let's confirm. So if we have, okay, we have margin of 0, right? And then we want to print it out. What would happen if a blank string is multiplied by 0? Okay, so if we do that, margin is not defined. Oh, okay, I'm missing the letter. Alright. Okay, so as you can see, we can actually highlight it out like this. Okay, so there's actually one space. So it's not like mathematics where anything multiplied by 0 is 0. Okay, what happens is if you multiply a string by 0, you will get just that string, okay, by itself, so nothing. Or is it space? I'm not sure. Let's add a space. Let's try and see if they're different. Okay, it's basically the same. So the result, there we go. The result is actually a space. So if you go back here and see the result, there's actually kind of like a spacing here, just one space, okay, before the 1 begins, alright? Okay, let's go back here. Next is it will print the following. It will print how many blanks there are, what is the current lower value, and what is the current upper value at this point in the recursive iteration. Okay, so what is the first number? It's 1 and 4, right? We're calling with a number 1 lower and the number 4 upper, so that's why it's printed out. That's why it's printed out as 1 and 4. Now, let's see. So the next is a condition, right? So if lower is greater than upper, why do we need this one? We need this one because this is our base case. So you always need a base case, a certain endpoint for your recursive function, right? So it will end the moment that lower becomes greater than upper. This is usually the tricky part, deciding what is the base case or the endpoint of your recursive function. So whenever the lower is greater than upper, what do you want to do? Well, you just want to print the blanks and then the value of 0 and then return 0. Okay, there should be a return value so that the succeeding function call will go back one by one to the previous function calls. Okay, now if that's not the case, what will happen is this else statement. What would happen is we would have the value of result, right, is equals to lower plus the summation of the next value in lower. So it's lower plus 1, okay? Because if you think about it, right, we have 1, right? It's, it's 1 plus 4, right? So you're 1 up to 4. So basically you're taking the lower and then getting the summation starting from 2 up until 4. Okay? Do you get the idea? So you're trying to get the sum of 2 to 4 because that's basically just the same as adding it manually like this. Okay, so that's the idea that we're trying to get. Okay, this solution is not directly you can't directly see this based on how we described the solution earlier. You have to think about it this for a bit. But yeah, so if you break down how you would add all the numbers, it's like this 1 plus 2 plus 3 plus 4, right? So it's 4 plus 2 7 plus 2 9 plus 1 10. Okay, so what you could have done is lower, which is 1, plus everything else, right? Now how would you represent everything else? So plus 2 plus 3 and plus 4, that would be just the same as calling summation and then with a value of lower but greater than 1, right? And then upper is still the same, but margin we can add 4 so that we can see the difference between one iteration over the next. Okay, one function call over the next. All right. Now when that is done, okay, since this is the return to 0, right? When that is done, and when everything else is, let's see, when everything else is done, it will go back here, right, we would have a value on result. So on our very first function call, it would go to print blank statements. That's the last thing that we'll see. But every succeeding call there would also show the blank sum result. This is what you see here. Okay, so we'll go over step by step afterwards, a value per value. Okay, and finally return the result. All right. So let's go back. Let's start with 1 and 4, right? So we have 1, we have 4. What do we do after that? We print the blanks, so we had the blanks. Check if lower is greater, so it's not. We go to else. What do you have? So you should be able to see this one, right? After the blanks, we print this one. So we see 1, 4, and then blanks lower and upper, yeah. So blank lower and then upper, right? After that, we would, Python would still be here, right? We're still in the first function call of summation. Now, since this is an else statement, Python will stop here, okay? It will see this one, all right? Lower plus summation, okay? So Python says, okay, I can't finish this function right now because there's another function inside of it that I need to finish first, because I can't go to the next line until I finish this one, right? So it saves that in memory, the first function, it saves it in memory, then it starts with this one, okay? So how do we start with this one? So we start with a lower, but a value that's greater than 1. And also for the margin, it's greater than 4, or added by 4. Upper remains the same. So what? Python will just take a look at this function again and then do the process all over, but with new values of lower, upper, and margin. So the new values would be 2, 4, and 4, right? So we start with the blanks. So there's 4 spaces. So it's this one that you see here. Next is, what you will see is print blanks lower and upper. So 2 and 4 with the lower and upper. So that's why we see 2 and 4 here. Okay? Now, oh, sorry. After that, lower is still not greater than upper. Okay? So Python will have to go to the else statement again. Right? Now it sees that lower, but the lower this time in the second function call, lower is equals to 2, right? And then plus summation of lower plus 1, right? So it's the same explanation as earlier, okay? So we are at the point where lower is equals to 2, and then you want to add 2 plus 3 plus 4. So 3 plus 4 can be represented by this function, right? Where the lower is just greater than 1. That's what really matters, right? Because this will become 3. So you represent 3 plus 4 by this, lower plus 1, and then call the function again. So it would become 3 and 4 afterwards. Okay, so that's what we see 3 and 4 here. It prints the blanks and then prints the blanks lower and upper, and then that's what we see on the output here, 3 and 4. Okay, now it keeps on repeating that pattern, right? It keeps on repeating that pattern. It keeps on calling the same function until there comes a point where this is finally satisfied. So where lower is greater than upper. So let's go back here. At the point where, let's see, at the point where lower is greater than upper, see? So 5 lower is greater than upper, which is 4. Okay, we can still see 5 and 4 because we print them out here before doing any checks, right? So we see that one. Then, since this is now satisfied, what do we see? We will see a output prints in blanks and 0. Now, at this point, the blanks will be will be equal for that specific iteration. So how many plus 4s is that, right? That would be 4, 8, 12, 16, so that would be plus 16 at that time. So when printing blanks, it will still be aligned to the same column, this one. And we can see that it will print 0, okay? So this 0 doesn't actually um, belong there. What's important is this value. Return the value of 0, okay? Now, we are gonna return the value of 0. Okay, so if we go back to this picture, right, we're gonna return a value of 0. So if you remember, this here is a representation of this number, right? But 5 plus 4 is returning 0. Summation 5, 4 margin is returning 0. So technically what would happen at this point, right, it will return 0 here. So it's just 4 plus 0, right? It's 4 plus 0. After that, 4 plus 0, it's gonna make that into the new result, and it's gonna return that result, okay? Alright, I hope you guys are following me. So it will return that result now, not anymore the 0. It will return this one. This will only trigger once at the very end of the recursion. Then it will keep on going to the next lines of code. Alright, so it will return the result. What would happen then? So 4 plus 0, right, because we were adding them, this becomes 4. The total here is 4. That's why we see 4 here, okay? Now, this number is represented by this one, right? If you just follow the output. So we can just, but the output of this one, the return for this is 4. So if we just go directly and see 3 plus 4, that would be 7, okay? Alright, so now we're at this point, okay? This is the return value, 7. Okay, now this number is represented by this one, 3 and 4, summation 3 and 4. Summation 3 and 4 is equal to 7. That is the return statement for this function. So if you add 7 and 2, you get 9. Okay, now at this point, 9 would be the representation of summation to 4, which is this one, this number here. Okay, now you return the value of 9. Okay, 9 plus 1, okay, that will give you 10. Alright, so I hope I'm making sense with my explanation here. This gets much easier. Before I had to write down each function call whenever this happens, okay, and I keep on tracking the values of the different variables to see how it's changing, and it will actually still look the same as this one, okay? Alright, so let me know if you have questions with the flow, okay, and I'll help clarify things. Other than that, any other recursive function will work the same way. It will just be different in terms of how you achieve the base case, and how would you, in what manner would you make it loop back to the same function call, alright, that you would represent the next following instances using the same function call. Okay, that's a trick. Okay, so here's a short here's another example. So the Fibonacci, right, if you remember your basic math, high school math, this is just a sequence of numbers, right, where the next number is the value of the sum of the previous two numbers. So 1 and 1, 2, 1, 2, 3, 2, 3, 5, 5, 3, 8, so on and so forth. So this is an infinite sequence, right? Now, the problem is, if you are trying to look for a certain value at a certain n, number, whatever n is. Okay, now we have to realize first that in the uh, description itself, it's already described there how how to make this into a recursive function, right? So there are very few cases where um, in the definition itself, it is also declared there the the way to make it recursive. In this case, it's very convenient for us because it's also indicated, all right? And that is the sum of the previous two numbers is the answer of the nth sequence of the Fibonacci. So if we say 1, 2, 3, 4, 5, right? So where n is equals to 5, you're looking for f of 5 is equals to 5. That should be the answer, right? Now, how do we do that? So we can say n minus 1, which is 4, and then plus n minus 2, which is 3. This one, number 2, will be equal to 5. Alright, so this is the basic formula that we should follow. Okay, now we have a basic condition where n must be greater than 2. Okay, why? Because it needs two numbers before. So if your n is equals to 2, you only have one number. Technically, it should be 0 and 1, but we just made it a bit simpler so that we can track it much easier. So if it's less than 2, it will just automatically return 1. This is what we have here. Okay, so if n is equals to negative is less than 3, it will just return the value of 1, and that makes sense. Okay, because if we try f of 3, which is the value of 2, so f minus 1 is 1, f of n minus 2 is still 1, so you get the answer 2. But if you say f of n is equals to 2, then n minus 1 is correct, is 1, but Fibonacci n minus 2, there's nothing there. Okay, so the Fibonacci sequence starts at 0. So that's why anything less than 3 will just return it by 1 because they're just the same. See? So I hope that makes sense. Alright, now that's the base case, right? Oh no, wait. Let's see. The base case here is less than 3. Alright, so this is counterintuitive, but we're doing this in reverse. Okay, we're going down actually instead of going up. So if you've noticed, we were working backwards. Alright, we're going n minus 1 and n minus 2. Okay, so earlier we were going up, right? The numbers were going up. Lower keeps on going up. That's why we have a condition of greater than upper. But this time, right, we know that when it is less than 3, it will always be 1. So we're going to be using that as our base case. So that's why we say less than 3. But then how are we going to work out the solution where it will always be equal to the sum of the previous two numbers? Well, you have to just deduct them. Okay, now n minus 1, n minus 2. So let's go back to our example. If n is equals to 5, right, n minus 1 would be 3. Okay, n minus 2 would be 2. So fib of 2 and fib of 3, each with their own representation of this formula. Okay, now the same thing as earlier, right? But instead of just one function being called, two functions are being called. One is for f minus 1. Python processes that, and then Python processes the next one as well. Okay, until they reach a point where n is less than 3. Okay, we're just going in the opposite direction for um, the Fibonacci sequence. Okay, so you can try this one out. It will definitely work. I think I've tried this one before, so yeah. Let's see. Recursion in the sentence structure. So basically, this is just like how the sentence program works. If you guys remember, we discussed something like that before. Let me just show you guys. Okay, this one, remember? Where we were thinking of creating a function, right, that makes sentences. Okay, and this was how it works, right? So from the data pool goes up to here and ultimately back to the main problem. Now in this part, all right, okay, we don't see, at least from what I see, it's not, I don't think this is the whole code. I think this is just part of the code. So we can see that it has random choice articles. It's looking for a random article, and it's also looking for a random noun, because that's what we need, right? We needed article and noun. Where's the article? Okay, these two to create a noun phrase. Okay, so a noun phrase. Okay, there's a function of noun phrase. And then it also has a random integer number from 1 to 4. Okay, so if the result is 2, 3, or 4, it's just going to return the regular phrase. But if not, it's going to add a prepositional phrase. So this is the condition. It actually starts from here. Okay, it always goes from articles to nouns to noun phrases. Noun phrases are always the one that is being generated first. Next, depending on the randomizer, it will either add a prepositional phrase before passing to the verb phrase, or it can just pass this one directly here. Okay. Now, when the prepositional phrase is being ran as well, it will get values from prepositions, and for verb phrases it will get values from verbs as well. So I hope the flow is kind of like this, okay, like an S, but there are conditions here, condition, and then condition here as well. So that's basically how that program works. Let's see. Infinite recursions. Yes. Alright. So just by analyzing the code, can anyone tell me why an infinite recursion will occur for this function? So there's just the three of us here. I guess I'll go one by one with you guys. So let's start with Felicity. Can you give me a guess or an answer as to why this will result into an infinite recursion? Hello, Felicity, are you there? Okay, we'll get back to Felicity. How about you, Paula? What do you think? This is an example of an infinite recursion. No idea. Wild guesses, maybe. All right, last call for Felicity. Not sure. All right. So if you take a look at the function closely, right, we have um, and n is greater than 0, right? Whenever n is greater than 0, we will just call the function itself, right? And the value of n also remains the same. Else, it will run forever, but um, it will give out a value of n that's less than 1. Alright? So the moment that you ran this program, let's say run forever 5, right? So is 5 greater than 0? Yes. So it will just call the function again with the same number. So 5, right? So after that, it's gonna call the same number again, run forever 5. And the condition still remains true. So it will keep on calling run forever 5, run forever 5, run forever 5. I hope you get what I mean here. So that's what's happening with this function. Alright, so I hope that makes sense. Okay, anytime you have questions, guys, let me know. Alright. Okay, so the cost benefits of recursion. Let's see. Well, the cost is actually memory, right? Because you keep on storing information whenever you keep on calling another function within another function. So, um, depending on the complexity of your program, it could consume a lot of memory, right? So each call of a function, the PVM, or what we call the process virtual machine, must allocate on the call stack a stack frame. We call it a call stack whenever a function is being ran or it's being called, right? So stack is because this comes from the, how do I say this? It comes from the comparison with plates, right? Let's say you have plates and then you're stacking them on top of each other, right? Now at the very bottom plate is the very first function call, and then at the very top is the latest function call, right? Um, so the latest function call. And in each of those plates, right, it saves these in memory as well. So the values of the arguments, the return address, or where the function was called, and then space for a function calls return value. So you need to create space for that one as well. Okay. So here's a good example, right? Imagine each one is a stack of plate. So call 1, this is one plate. Call 2, this is another plate. Call 3, call 4. Now as you solve each function from the top, you keep on going down as well, essentially solving it for the entire tree. Okay. By the way, if you see the website called Stack Overflow, alright, so if you are um, searching for explanations, solutions, or exercises on the internet, this will be your best friend, Stack Overflow. Now, quick trivia here. It's actually called Stack Overflow because of this concept that I just said earlier. That memory will gradually be filled up, right? Okay, so there's a lot of plates already in the memory. And then it's not loading. Anyway, okay, here you go. So the thing that I want to point out is this one, all right, the image. So you see that there's a kind of container, that's the memory container, and then each orange is a single call stack, all right. And using that, okay, what does the call stack retain? It retains the values of the arguments and the location, right? So the result here will be passed to the lower one always. Okay? Alright. Namespace, we don't actually need this one at this point. Basically, a namespace is a container that holds a set of names um, and their corresponding objects. So basically, the main use of an essay is just for organizing code, avoiding naming conflicts, encapsulations. So naming conflicts, right? You can have two scripts with similar file names, but you can never share them um, directly. Um, yeah, to like ask permission for it. But yeah, anyways, the namespace, other IDEs would require this one, but for uh, Jupyter Notebook, it doesn't really. Okay. What other benefits that one have? It has scopes, so global and local scopes. It will be easier to see with the namespace. All right. So just think of it as one big variable that separates other parts of your program, kind of like an organizer. But that's just it. We don't really set that one up in Python. So here, this program is the example of the doctor program. Remember that one? So we had, let's go back up. Doctor program. It's not here. Mm, should be here. Ah, okay, this one. So this was the doctor program, remember? We are trying to, this one, create the function for change person. So let's see, shall we, how that was achieved. Okay, so we have replacements here, basically just changing the person. So from I to you, me to you, and so on and so forth. The function in question here, let's see. Okay, so it's splitting the sentence, has a variable that's sitting beside it, and then let's see. So in the loop here, you can see that we're trying to append, right, the equivalent replacements on where that word is. So if it sees an I, it will change it to you, and so on and so forth. So that's how this function works. Okay. Module variables and double variables. I think this is okay right now. We already know parameters, method names. But this one, yeah. So for temporary variables, they receive their values as soon as they are introduced. All right. Um, module variables can just actually be uh, only works when you're using the actual module itself. I think that's it. So yeah, I think that would be a good description for that. Scope. So scope is just a limitation of what you can and cannot access. All right, what variables you can and cannot access or change. All right, so temporary variables are restricted to the body of the functions in which they are introduced, like what I said earlier, invisible to outside function definition. And the scope of module variables include the interval below point where they are introduced. All right, so basically if you have like a variable inside of a for loop, right, the very first line inside your for loop, any succeeding loop or function call or yeah will have access to that variable. All right, now can the global variable have access to the one that's closer? So technically no, right? Because the global scope can't actually see that one anymore, so that's why it's being ignored. All right, so that's for variable scope. Let's see. Oh, here's a quick and good example. You have attempt here to change the value of x. Now x here is a global variable. X here is a local variable, right? Um, but when you're trying to print x, the one that will see is the x that belongs to the global function. This, or the global scope, I mean. This variable, its scope is limited to the function itself, so it will only exist there. Alright, that's the concept of it. Lifetime. Let's see. Period of time when a variable has memory storage associated with it. So basically this is the period of time when the variable has, let's see, lifetime. How long before it's being deleted? So for a global scope variable, what would happen is that if it was a global scope variable, the lifetime of a global variable extends throughout the entire system. Okay. So if you have settings like that maintains a certain part of an app, for example, then those settings must be globally scoped. Why? So that uh, they can be attached with other variables that don't actually be in the global scope. So they can use that as a reference for any other things that they might do. Okay, so yeah, I think that's it. That covers the whole thing up. Using keywords for default and optional arguments. So we actually have discussed this one in the very first session. So remember on the print statement we had there something like I forgot the parameter. I think it was called parameter for print. Let's just do a quick Google search. Oh, it was and, right? There was an and. So that itself is an argument, remember? But if you put a key there, right, then it will become a key argument or a keyword argument, right? So when the function is called with these arguments, default values are overhidden by the caller's values. So what I'm trying to say is, if you were calling them by name, right? I think I gave an example of this. So you're calling them by name, and they can be placed any part of the um, they can be placed any part of the function declaration, and then it will still work because it's calling the property by name. Okay. What else? So this is a code that converts, what's this? String representation of numbers in a given base to their integer value. So this is something similar to what we did earlier. Right. Let's see. So as written, this function can be used to convert string representations in bases 2 through 10. Alright, so all you have to do is use this function whenever you want to convert, again, from decimal to octal, decimal to binary, or decimal to um, base 2. So hex is not actually shown here, but it should still work, I think, if it was hex. You just need to change the this part. Okay. Default argument. So this is when on the function definition there is already a value assigned to that special key. Meaning, for that special key, if you just leave it blank, it will just automatically use that one by default. That's what it's trying to say. Okay. Now, if you have, like this example, option 1 is equals to 2, option 2 is equals to 3, you did not declare those either by how do I say this? Even if they were not declared, okay, they can still function properly. Alright, it will not return an error because water is still no, water. I'm thinking of a different example. Say this one, right? I think this will be good. So the last one says here option 2 is 20, option 1 is 10. They are not in order, right? But this will still work because we're calling the parameter by name and giving it the argument directly to that parameter. Okay. But if this was not present and you would want the same result, that will not happen, right? If you want the same result, because the default value of option 1 is 2 and the default value of option 2 is 3. So this is not going to work if this is the call, right? You're calling this one, but since you're overwriting it, it will use these values now instead of 2 and 3. Higher order functions. All right. So higher order functions expect a function and a set of data values as arguments. So it's like you're you're passing a function as an argument. Okay, you're passing a function as an argument. So a very popular uh, function would be the map, right? So if we go to map here, I think map, yep, mapping. What's these examples? First class. All right. So basically, what we're doing is making equivalents of different functions, right? So this list here has absolute and math, that's square root, right? Let's see, abs, abs, so it's this one. F of negative 4. Okay, just give me a moment, guys. I'm trying to see the code. Alright, so this is the function. ABS is the function. This actually comes from math. So what it's trying to do is making an equivalent variable. Now making a variable that would be equal to calling the ABS if you treat f as a function. So if we treat f as a function now, right, it will basically work the same as how ABS would work. Okay, so yeah, instead of using ABS, you can just call directly f. That's basically it for functions as first class data objects. So the thing that's great about this one is that the example is actually quite simple. Let's go to the more practical one, which is the mapping, right? Now, mapping, filtering and reducing, right? Filtering and reducing actually comes from mapping. So if you actually understand how mapping works, you are so able to understand much more easier reduce and filtering. Okay, so what is mapping? Okay, mapping applies a function to each value in a sequence. All right, in a sequence, so this could be either a list or a dictionary, if you guys remember. But in this case, we have a list. Okay, the format goes like this. So in map, it will go to the variable int and also the variable words in this example. Okay. After that, what does this mean? So, words now is actually equal to 2, 3, 1, 20, 45, and 99, the same as this one, right? So that would be um, 0 times map object and all right, so words, right? So map int words. Um, what would happen is 231, not this one, not 0 times. What would happen is 231 multiplied to the function int, all right? And then saves that one into part of the list, goes to the next item on the list, and use the int function on that to convert it to a different uh, data formats. Okay, so from string, it became numbers. Okay, so that's very important, especially if your purpose is to use it for um, other things. Okay, change sentence, change person here. Let's see. Mapping, I think it's on the next, yeah. So map here is get word and then sentence dot split. So whatever you get, right, it will have to be converted first into a list of properties. Um, Afterwards, it will just return with the list. Okay. So I'm kind of moving a bit faster here because we still have to go to the other PowerPoint. But starting from recursion up to this point, it's not really like mandatory that you have to use them. It does make it a lot easier, but it's not really like mandatory to learn these things. So before I try to avoid these, so filtering and the map, because it really confused me before how they work. So I decided to master the basics, like the for loop, the while loop, the ifs, how to manage them, the different conditions before um, actually using these things to make a shortcut. All right. Last few slides, I think. All right. So using lambda to create an anonymous function. Again, this is one of those things that are not really something that you need at this moment. But the great thing about a lambda is because it creates anonymous functions. When you say anonymous functions, it means there's no filter. Or, is that correct? Filter. Um, Not filter. There will be no like name per se of the function. Okay, it will just go directly to comparison operators. When it's true, it will choose one. If it's not, it will choose the other. Okay. What else did I miss from lambda? So same as before, I don't use lambda a lot. I tend to do only the necessary stuff. All right. Okay. Here it's just basically the same. Jump tables are something that you created before, right? But it's not here. That's okay. See. Next. Oh, this is actually the last. Alright. So we're finally done with this PowerPoint. We'll have to move to this one. Alright. So finally you're gonna do your first step into data science, which is web scraping. Okay. So yeah, this is still used a lot today, um, just to collect data. All right. So yeah, let me unshare this first, and then uh, so we're finally to web scraping. But before that, let's actually take a quick break, 10 minutes, and then we'll be back here. Okay. I'm gonna start the timer so that you guys know that I'm still here, and just taking a break, quick break before we actually begin. Again, difficulty will spike starting at this point, up until to the end. So yeah, um, just digest them as they go. Right? If you have questions, raise them. I see Patricia is joining us. Okay, so that's good. Okay, so web scraping. Let's go here. Alright, so before we actually um, scrape something off the web, we have to understand first how it works. Alright, now here's a diagram of how web scraping basically works. So in our browser, right, there's something called the fetch. So it's a kind of command. Okay, and let's say we're opening a page. All right, so you can see here, using requests, what we are aiming to get actually is something called the HTML file. Okay, now from the HTML file, we want to extract something called the HTML tree, just this one actually, what you see here. This one. So it's not basically a tree, but you know the way that it looks, that's why it's called an HTML tree. All right. Now, what are we gonna use? We're gonna use something called the beautiful soup, all right, to extract the data. Okay, now let's respond. There are different programming languages that you can use to scrape the web. That's true. It's not. It's not. There are other libraries, and it also exists in other languages as well. To scrap and extract any information from the network, probably need to go through three stages. So that's fetch, HTML3, and then extraction. Okay. So we need to understand how HTML works first. All right. So, does anyone here have experience to um, using HTML? So if you have, just give me a thumbs up. If not, a thumbs down. Okay, so I guess no one. All right. So HTML is not actually a programming language per se. It's more like the structure of a certain web page. Okay. Everything in the HTML is defined with tags, right? The most important one is the HTML, which allows us to write HTML code inside of it. Um, each tag also comes with a pair, right? So as you can see, it's like HTML and the other one. There's also a closing tag, opening a closing tag. The closing tag is with a slash in the beginning. All right, so that's the closing one. Um, they always come in pairs. There are some where it's a bit special because they can function even though there's no closing tag. But if you were to put a closing tag for them, they would still work the same either way. So um, yeah. So each tag is more like a different part of the web page. Okay, so head is like for um, where we declare what are the different things that come with the website. Like if you were to request some specific resources or specific properties like the title of the website, that goes to author, something like that. So you declare those things in the head. All right. Um, the body here in this case is what you see basically on your screen. The web page itself. So whatever you see, that should be also inside of the body. Okay. So we're not gonna discuss the whole um, all of the tags that are available for HTML. Okay, we're just gonna um, we're just gonna discuss what we need and then the most common ones as well. H1 is a header basically. UL is like a list, unordered list. So if you have a list that's like, it can be they can be just in bullet points, so that's an unordered list. If it's with numbers like 1, 2, 3, um, you put them inside of a ordered list or OL. Both of those lists will have list items, so that's the LI that you see here inside. Um, Also, what are things? So those are the tags, right? In between the opening and closing tag, there is the inner HTML text. All right, so this is the actual thing that that you see um, on your body, right? Or some certain properties in the head that you can also see, like the title. Okay. Now, H here, H1 is header. There are four, I think five types of header. So it's H1, H2, H3. So the bigger the number, the lower the font size. Okay, so if we were to rank them, H1 would be the highest level, and then H5 would be the lowest. So kind of like how we would divide it into different chapters. So chapter 1, that should be, oh no wait, chapter 1, yeah, that should be um, H1, right? Inside of chapter 1, there's like um, divided into different topics like chapter 1, part 1, part 2, part 3, and so on and so forth. So that's how each one works. So all of them basically have inner HTML text, okay? All of them also have attributes and attribute values, although the others, there's no declaration of it. This is how they should look like. So UL, right? ID is supposed to list. Um, so ID, the attribute ID, has a value equal to list. All right. Now class here has a value, attribute value of equal to cool list. All right. So if you, you know, observe, they kind of look like keyword arguments, right? They kind of look like keyword arguments. So they have the same kind of format, right? Or if you're if you want to compare it to functions, they look like parameters, right, with default values. So it's essentially the same thing. Okay, that's how they work. Okay, the only difference is that the values are always going to be in uh, string format or in between open and close quotes, double quotes. Alright, so here is the top 10 HTML tags. Um, the things that I haven't discussed yet is, let's see, oh wait, it's up to H6 actually, so I forgot one. Anchor tag, so the anchor tag is, we use that one whenever you want a link to appear on your screen. So it doesn't have to like appear, but basically you put an anchor tag if you want that certain part of your website to be the link. Okay. P, short for paragraph, so content itself. So if you have like parts of your website that, you know, it's basically the content, right? So if you're into cooking, that would be like the steps on how to cook it or how to prepare, so on and so forth. Div, all right. The div and the span, right? These are things that you use to have some division in your page. Okay, so if you have like if you're confused, like what am I gonna do to divide these two things, like um, so none of the other elements would fit, right? So that's why they put something like this, because if you're confused, you can just actually use these two. They function as sort of a separator when you need them. Okay, the only difference is div is for the page, the home page. The span is around some items. So if this is one sentence from 10 up to web, the span would be like, if you want to change the color of scraping, that would be span. You would put span around the word scraping. But if you were to use div, it will be the whole thing. Okay, that's the difference. Um, okay, you don't actually need to know like deeply how to use them, because you're not going to be searching for them. You're not going to be typing out, but you are going to be searching for certain elements when you're doing web scraping work. Okay. Last but not the least is table. It's very common in sites where you're looking for um, specific data. Okay, so usually they come in table format, and if it's in a table format, especially if it's the only table on the page, then your work becomes a lot easier in extracting that information. Okay, before anything else, I want you guys to understand what we're trying to do with web scraping, right? So imagine yourself like this example. If this whole thing was a table, imagine doing it yourself, like manually looking for it, and then copying the information and then pasting it somewhere, like I don't know, maybe Excel, okay, whatever um, application you want, and then doing that for every other item that you see, okay, that is similar to that one. Let's say, for example, you have a list of students, 100 students, for example. Each student have their own list of favorite things, right? And each of those students has their favorite things at a certain part of their website. So this is the page, for example, and it's stored somewhere here, the table. So if it was you, what would you actually do? You would click on the name of the student, highlight the table, copy, and then paste it to your app. Go to the next student, copy, paste, go to the next, copy and paste. So you get what I'm trying to say. So that's what you're actually doing. Web scraping, right? It's just similar to that one, but you do it automatically. You make it do it automatically, all right, using Python. And this is where it becomes an advantage, because what if the data you're looking for is like thousands of data, right? Let's say you're looking for book informations or flight informations, right? And then there are over a thousand, a thousand information or 10,000 um, flights that you need to take a look at. So you need to get all the information for each of those flights, right? So it becomes really a hassle if you have to do it one by one, okay, if it was a person that was doing it. But if it was Python, right, or a different app, a web scraping app, then it would be really easy for them to get data like that. Okay, so they like repetitive tasks like that. So that's where they shine the most. Okay. All right. So that just want to make sure that everyone knows what we're actually using web scraping for. Okay. So, all right. So we're gonna have to install Visual Soup. Let's see. Explore, fetch. All right. Okay. Okay. Let's go ahead and type this one first. So it's just a basic HTML followed by head, body. Head, that's just a title. H1 is within the body. UL, 3 list items. List ID, class of cool list. Okay. Let's type this one out. Right. First as a, let's save this one as a string first. Anyway, we can just copy and paste that one as a file. Part of a file later on. Alright. So let's think we can do this one. Yeah. So so HTML accepts, okay, if this was a file name, some string, HTML, okay. Alright, so there's, yeah, you can proceed with this one. So you can use this one, this format for a string with multiple lines because it didn't really say, but it says some HTML string. So we have to save this one as a string first, and then later on we can try and move that into a different file, then access that file, and then um, read the contents of that file and then do the same thing. The importance of doing that is because when we automate something, we are downloading the HTML, right? So the HTML will be saved either in a variable or in a different as a different file. So you need to know how to do both. All right. So if we say how was that HTML? This one, right? I don't know if I can actually type here in HTML directly. Can I? No, it's not responding. Can I declare the language Python? Which one would be easier? Because if you were to new file, I'm just trying to create something, okay? Sample HTML. Alright, so HTML, language, English, indentation, keystroke, editor theme, let's see, theme, syntax, highlight, and let's try this one. If it works, HTML, there you go, okay. Alright, so the reason why I was looking for this is because it automatically adds the closing bracket the moment that, the closing tag the moment I use, or close the opening tag, so like this, yep. So it automatically comes out. So HTML, head, and then outside of head, inside of head we have title, and then this is my title, the text, right? Title, here it's body, inside the body is h1 is sample header, and then this is a UL, right? UL has an LI, oh no wait, not an LI, an ID of list. No, that's not allowed. By the way, for HTML, it always has to be double quotes, but you know, that's not gonna impact you in any way because you're not creating the HTML code. what's the last one? The class, right? The class is equal to cool list. Cool list. Alright. And then I'm gonna close it. Oh, it's not closing automatically. There you go. Enter, and then I have three LIs with item 1, 2, 3, 4. Was there 4 items? Was there 4 items? That's oh, it's only 3. Sorry. Okay. So I'm gonna copy this one and then go here, paste this one here, and then we have our HTML string. Okay. So I'll leave it at that for now. We save it. Save text. Alright. Okay. Alright. So we have our text, but we need to install first Beautiful Soup. So you're not going to be following this command, okay? You are going to be doing something else. So I'm going to go to a different screen because I'm just sharing my window. So I'm going to share, let's see, my navigator. Here we go. So how to install library. So this is how you're going to do it. First is on your navigator, you need to go to environments. Okay. Now in environments, you need to click on the channels button. Okay. So the channels is like, if you click on it, you will see this one. I don't know. Can you see it? I don't think you can. Show me what I'm sharing. Okay, so can I switch to that one? No. Alright, so I can't share that one, but what you should be able to see is the different channels that Anaconda is getting libraries from. So by default, you will only see one, and that's from Anaconda, right? Now, I need you to add something else, a third-party provider that gives us access to all the other libraries that Anaconda does not have. Okay, so even though this is a third party, this is actually pretty safe. A lot of developers use this one, and we can use that one as well. So actually, if you go to conda conda.anaconda.org, all right. So Conda.org. Let's try Conda. It's not coming out in my search. Okay, so it's in conda-forge.org, and I think they are actually, yeah, registered, um, you know, connection to Anaconda. So let's see. Oh, I forgot. I'm not sharing my screen. Anyway, click on channels, right? In that box, you should be able to see. I think it's better if I just. Hopefully, I can share the whole thing, entire screen. But I'll just. Alright, that one for now. So hopefully it won't lag. Okay, so now you should be able to see what I see, right? because I'm sharing the entire screen. So when you click on channels, right, you should be able to see this box, right? And inside here are all the different channels or servers where Navigator is connected to get the libraries, okay, to look for the libraries that you're requesting. What you need to do is to click on the add button. All right, what you need to do is put this, okay, I already have it here, but you need to add this one by yourself. You need to type this one, so https :/conda.anaconda.org and then conda dash forge / okay. I'm gonna send this link to everyone in the chat as well. Okay. Alright. conda.anaconda.org / conda forge. Okay. After that, what you're gonna do is to press enter on your keyboard in order for it to be included on the list, and then click on update channels. Okay, it's gonna load up a bit, and then when it's done, right, it should be somewhere around on the lower right, I think, the loading screen or the loading bar. Check if it's done, right? So it should look like this, right? Your Anaconda Conda dashboard should look something like this. Okay, I think in your case it should be defaults and then this one. Okay, there should be a trash can icon on the right. Okay, after that, go cancel. So what you should have here, currently what I have here is filtered into installed. All right, but if you go to all, okay, it will show everything that you have installed and also that you have not installed. Basically everything that's available from all the channels that you have. Okay, so yeah, everything that's listed here you can download and then apply it and use it in your projects in Jupyter Notebook. Okay, now what we're doing basically is just point and click, but if you were to do this the traditional way, we would have to type in some certain codes and then do some certain setups depending on what language you're using. Okay, so it might be more difficult than this, but here, since we are in the Anaconda environment, right, they do that automatically for us. That's why I like this one in terms of trying out new libraries, right? You don't need to have that extra layer of things to learn about just to be able to use the library. Okay, so they kind of like abstracted the whole thing for you. They do it for you. So you're more focused on the actual thing that really needs your attention, which is the data science part, right? Okay, now let's see. Alright, yeah, we're gonna search for the BS4. So if you click on here, search packages, remember to set this one to all, otherwise you won't be able to see it. Okay, set this one and then search for BS4. BS4. It might lag a bit, okay, but it should show this one, BS4. So this is a Python library designed for screen scraping. BS is short for beautiful soup. Alright, now in the PowerPoint, if you remember, it will show that we need to pip install BS4. This was one of the commands that you would do before, right? But again, if you were to follow that one, you need to do some additional setups, which is kind of annoying, and sometimes it can have errors in your system, right? So yeah, let's just skip this whole thing and just use an content navigator. Um, so where was I? Okay, yeah. What you need to do is click on the box on the left. Okay, make sure it's marked checked. This one as well. For example, I'm going to be using this. Okay, so if you click on the box, it's not going to be checked. It's going to be a down arrow. That means you have to download that one. Okay, then you have an apply button here, right? So you click on apply. Let's see, two packages available, one package selected. All right, so you click on the box, but make sure you're selecting this one, okay, BS4. You click on apply. So after clicking on apply, this should come out and then install the package for you. Okay, now I'm not gonna be installing this one. Okay, so I'm just gonna go click on cancel. And yeah, I think that's it. After that, it should say that, or you should be able to see a check mark here instead of a down arrow. And then here, what you would see is the version number of the one that you're currently installed. Okay. Um, yeah. So if anyone's trying it out, let me know. Um, it depends on your internet. And tell me afterwards what comes after clicking on apply. Like, is there an additional dialog box that comes up? Because from what I remember, there should be no dialog box. It should be done. Like, you could just see the check mark directly and then use it immediately. Okay, so yeah, I'll wait for you guys to uh, tell me, okay, what appears afterwards before we can proceed. So everyone needs to actually be able to install that pip PS4 before proceeding, because we can't really do this without um, beautiful soup. Okay. So can anyone give me an update? Felicity, Paula, mine still loading. Okay, that's good. Um, all right. How about Felicity and I can't see the name. Patricia. I think it's installed now. All right. Can you like also share your screen so that everyone else can see as well? Like, is there any? So that was Patricia. Yeah, Patricia, can you try and share your screen? Is there any other window that appeared um, after clicking apply and then the loading screen is done? Let's see. PS4. All right, so seeing that
I think I just
there was no other comment, then I guess that should be it. So after clicking on apply, it's done loading, then it should also look like that. See, if you guys can see Patricia's screen, it's just, a check mark will just appear automatically. All right. So thank you for sharing that one,
I think
Patricia.
I just click apply
So let's wait
twice
for the others, all
and
right?
then yes.
From my experience, others have, installed it quickly, like Patricia. Others have took a few minutes. I think it depends on what net are you using, what ISP you're using. I'm not really sure, but so far PLDT works, but just like now, PLDT is very slow, so I have to turn off my camera to save bandwidth in order for my share screen and my audio to be clear. All right. So yeah, Paula and Felicity, I'm waiting for confirmation on your end. So it's just gonna be with who's online here today. For the others that are watching the recording, um, yeah. So hopefully everything that you've seen is enough to help you install it on your own. And okay, let's wait for the others. So meanwhile, yeah, type this one out as well on your end. You can do the same thing as me. Create a text file and do it like this, copy and paste, or you can just directly do it here. It's up to you. So right now, this is just a very simple HTML string, but in reality, if this was actually working, right, this would have been what we've downloaded from a website, okay, um, using Python, and then accessing that string. So it should be much, much bigger than just this, okay? Right now, we're just working on the concept first. So start something small and then work on the complex stuff later. All right, any update? Paula, Felicity. Mine's taking long. Yeah, that's okay. Yeah, it really varies depending on the device and the speed or the ISP. The longest that I had with my other student is around 15 minutes. So, yeah, as long as it's moving, the bar is moving, I think there should be no problem. So I'm still waiting for an update from Felicity. So she has no message as of now. I need to wait because before there was an error with one of my students. So it's not always present, but I'm not really sure why those errors occur. And then uh, we had to troubleshoot it together before proceeding. So later on, when we still have time, we're gonna be scraping an actual website, right? Um, and when you can do it once, it's basically the same with every other website, just different complexities. So the difficult parts would be if a website has logins, if a website has infinite scroll, like the content will load only if you were to move the screen, like Facebook, right? If you keep on scrolling down, it just loads new data. So it's not actually the web page is not fixed, it's dynamic. It's loading data as you are using it, the web page, right? So that's a bit tricky, but the entire concept is the same. You're just adding an extra layer of step there to take care of that, okay? Um, or maybe the site has different pages like page 1, page 2, so you need to cater that one. But once you get the idea of how to do it once, you can apply it to different things. You know, Hello, Felicity. Are you still there? Okay. How about you, Paula? Is it still loading? Yes. All right. Um. Okay. Let me know if it's done. I think we'll just proceed for now to save time. So earlier I lost my net. That's why. After the break, it took me a while to come back. But you know, let's see. We're running out of time, so we'll just proceed and just follow along later on. Okay. All right. So we have installed pip. Now let's see if we can make this one appear in Jupyter Notebook. Take note, these steps, right, will be the same whatever IDE you're using, not just Jupyter Notebook. It's just that if you're using a different one, there will be extra steps that you have to do it on your own. Okay, so if you're more into like Visual Studio Code or Sublime, then you would have to do some extra steps. All right, but technically they would have the same output. Okay, so here, okay, so we have that HTML string, right? What do we do? We say from Python dot core dot display import. You can't see your screen. Oh yeah, sorry, I forgot. Window, this one. Okay. See what I'm sharing. Okay, yeah. So ipython dot core dot display import import um, display and HTML. All right. What's the next one? Next one is display HTML and then call the string itself. Okay, so display, and then HTML, and then inside here is the string itself, HTML string, or whatever variable we were using. Okay, run it. There seems to be an error. Module named Python. Okay, it's capital I. Need to be careful with the spelling. Alright, so as you can see, I made it appear here. So now Python technically is able to read HTML. Alright, take note this is just HTML that is like there's no styling, there's no links. Okay, this is just basic HTML. Okay, the backbone, right? That's what HTML is. It's the backbone. It's where everything else on the web page is attached to. Okay, just like our human skeleton, it is where everything is attached to. That's how HTML functions. Okay, now so we can display it like this, right? It's able to render it like it was an actual page, so that's good. That means it was able to um, read this one, the HTML itself. We have this warning. Let's see. So it's just a warning, not really like an error. But if you want to remove that warning, um, what you can do is instead of core, you can remove the core and just go directly to display. All right, there you go. So that will remove the error. So this is a previous version. Right? This code is from a previous version. When you see something like the word deprecated, that means they removed that from the current version. That's what that means. It can be for any reason, like maybe security or maybe something better replaced it. But when it is deprecated, that means it's not being used in the current version. Okay, so this is how it would be if we were to access um, if it was a string, if the HTML was saved in a variable in a string, okay, but if it was in a file, right? Let's see. I want to rename this one. Instead of dot text, I want this one to be HTML. It needs to be HTML, by the way. Rename. Okay. If I were to save HTML file, and I were to open this one again, like see, now take note it changed, right? Jupyter Notebook, Jupyter was able to recognize that the file is now an HTML file, so it will appear like this HTML5. Okay, it's the icon is rather small, but it should look something like this. HTML5 should have this kind of icon. Okay, uh, if it was bigger. Okay, where are we? Alright, so now that it's an HTML file, if you double click on this, it will be read by the browser as a HTML file. That's why you can see it like this directly. And you can also see that in our notebook, it is the same. So uh, we have confirmed that it's working properly. Okay, when you double click on the file, it's reading it like it was an actual web page. Okay, and the browser is loading it like this. All right, now what's next? So we're able to read it. Next is we need to understand the HTML tree that we have. Okay, so now if you take a look at this, all right, it's basically the same as this one, but only sideways, right? So take note. Remember how we were like adding tabs in Python to indicate nesting, or if it's a group that belongs to under something else, right? So in this case, head, okay, and body belongs to HTML, right? So you can actually see that here, head and body, right, under HTML. In code, it should look something like this: head and then body belongs to HTML. Under head, there should be title. Nested under head, there should be title. You also see that one here. Head, title. For the body, there should be a h1 and a ul. h1 and a ul. And then here under the URL, there are 3 list items. So li, li, li. That's basically what the tree is. Okay, so it's just this, but in like a flowchart format. Okay, now the importance of this is that once Python understands, right? When you hear the word understands, sometimes the jargon that they use is parse. Okay, when you hear the word parse, it means to understand. So once Python parses or understands the HTML tree, right, it can basically move from any part, from here to here to here. It can jump all around. All right. Now, why do you need Python to jump all around? It's because you're looking for a specific part of data on the web page. Okay. So it just so happens that the specific data that we need is very small. It's in this list, for example, right? This is the thing that we need. This is what we're looking for. So in order for Python to get there, it needs to know how to read it. That's why we need to make Python parse the HTML tree. Okay. Now, oh, it's also here. Okay. So now, right, it's time for us to use beautiful soup. Okay. I actually haven't discussed this part yet. So we're using from, right? So whenever you use from, okay, you're trying to refer to a specific library. And then you say import because you only want to use certain functions. You don't want to use the whole thing, right? Because if you wanted to use the whole thing, you would say import IPython display, and you would be importing everything. But no, you only want to import the two functions that are necessary. So display and HTML. Okay. From that, okay, you should also separate all these declarations. Okay, they should almost always be at the top. So let's move this one. Okay, as a good coding practice, these declarations, right, should always be at the top, followed by the body of your code. Okay, so what do we need next? We need to use BS4 or Beautiful Soup. Beautiful Soup is stored in BS4. BS4 is a group of libraries. Okay, so if it's a group of libraries, you only want to use one. Okay, so from BS4. Okay, this is the whole file. You're telling Python you only want one. So import beautiful. So this is beautiful soup. And then you put as BS. Okay, the as here is like an alias. It's very tiring to always write beautiful soup, especially the cap BNS, right? If you're typing too fast. So we just gave it an alias as BS, okay? Sort of like a variable in a sense, but you can just call it using BS. All right. Now, um, let's see. So from here on, we need to pass this, like what it's doing here, to Beautiful Soup so that Python can parse it. Okay, right now what we have here is Python only has the HTML string. It can read it using IPython display and HTML, but we need to let it parse. Okay, so it hasn't parsed yet. The one that makes it capable of understanding HTML is Beautiful Soup. Okay, earlier we just made it display, so the one that was parsing the HTML string was display IPython. It was actually IPython. It was something else. It was not Python. Um, it was not our program that was reading the HTML per se. So um, we need to add that capability into our program. So let's comment this one out first. And then we say soup is equals to BS, right? And then pass in the HTML string here. HTML string. Okay, this is assuming that the HTML string here, we have access to it directly, like this one. So it's not from a file. We save the HTML itself that we have downloaded from the page directly into a variable. And that's okay, because if you remember, the variables in Python are self-adjusting depending on how big your information is. You're trying to put there. Okay, now if you were to go to the documentation, right, of Beautiful Soup, where is it? Okay, you would see that this is the recommended way of accessing it, right? Save it to a string, a variable, and then use BS, pass it, and then it creates a Beautiful Soup object. Take note, it's now an object after this one. This function okay, returns a beautiful soup object. So what comes after that, if it becomes an object, we are now able to use the properties and methods that comes with it. All right. Now here are some of those functions or methods that we can do um, to navigate the HTML tree. So we have the find and find all. They have mostly similar parameters as functions. So name, attributes, recursive text, and the quarks. Quarks is short for keyword arguments. All right. Now name, the name of the HTML tag to search for, you can put that there. Attributes, if you're looking for certain attributes. Recursive, if it's true, means that you need to look for the entire tree or on the immediate children only. So depending on where your data is, you can set this one to false or true. Text would be the exact string itself. You're looking for the one in the middle. Okay, if you remember this one, you're looking for this, the one in the middle. Um, and then limit is the number that it matches to. Okay, now take note, find only returns the first occurrence of the search. Find all returns a list. You need to read the description, right? It returns a list, so it will be a list of all possible matches. Okay, right. So if you need more information, you can search for it here. Beautiful soup. It's a fairly um, well-maintained library. A lot of people use this one to scrape websites. This is a documentation. It's just one whole page, static page, and everything else is just linked to the contents on the left here. Okay, everything you need to know about Breathable Soup is in here. It has a quick start. You can compare that one with what we have. Um, and also the basic way to use it. Okay. So if you ever like um, get the question, is this available in Beautiful Soup? Then this is where you would go. Again, uh, the expectation when you're working as a data scientist, right, is you have about 1 week. About 1 week, right? They're gonna tell you, hey, we're gonna use a new library. Try to read the documentation. So when they say read, you have to actually read it. Um, at least once read the whole thing and then try to go into the different examples, right, on how to use it. Just by going through the examples, you can kind of get already how to make it work, right, in different situations. And then after you're done with the whole thing, you're kind of halfway there, and then you just need to do maybe some simple projects or test projects to really familiarize yourself before actually applying it to your work, right? Um, but yeah, okay. So we're not going to be discussing this one. This will be for you guys, okay? This is your assignment. You have to read this one, okay? All right. So where are we? Okay, so now it's a beautiful soup object, and then from here we can use find and find all. Okay, so let's see. So here are some examples. We can just follow this one. Right. Let's say we are looking for the H1, right? So how do we do that? So you say, let's just print this one directly. Print, right? And then the soup dot find. So if you're looking for the name, okay, you have to indicate it in string format, like this, H1. And then if you were to run this one, you will see that it will print out the exact same thing that we're looking at, okay? All right. If you were to, what was the next one? So we need to look for the text, the li, the find all. Okay. So here we need to print soup find, and then you're looking for the text, right? Let's say you just want to access the text. So um, if you go over the documentation, you'll find that once you have access to a certain object, right? So soup find and then h1. H1 here, this entire thing, the result of this, okay, is still a beautiful soup object. You can still treat this as a beautiful soup object. Then that means you can continue with another method. You can chain methods, so to speak. So soup.find dot text. So if you say dot text, then you should be able to access what's inside the header here. So if you run this code, you will be able to access the text itself. So the difference is this one, it's still a beautiful soup object. This one, since we are at the endpoint, the last part of the data, then it's gonna be a string already because this is a property, not a method anymore. So it's not a beautiful soup object anymore. It's just a regular string object. Okay. The next one was an li, right? So print soup dot find li. I'm running out of batteries with my keyboard. So li, there you go. So it shows us the item 1. If we were to use find all, right, it's underscore find all, it would give us a list. It's not scrolling down. Okay, there. Alright, so we have a list, right? So from this point on, what do you remember from list? We can, okay, this whole thing right now returns a list, right? So this whole thing is now a list. We can treat this whole segment of code as a list. So what do? Let's say you want to access the first item. So you say subscript operator 1. Alright, so you are accessing that one, and that is still a beautiful soup object because it's still in a like an HTML format. So that's a good indication, by the way. If it's still in that format, that means it's still a beautiful soup object. So I'm gonna access item 2 and get the text property, and there you go. See? So this is the part where it gets confusing, right? I was accessing, right, a beautiful soup object that became a list. I accessed the index 1 of the list, and then from here on out it became a beautiful soup object again. And from there I accessed the text property, which gave me a string output in return. Okay, so we're going to the part where we're mixing up different data types, right? We're moving back and forth between different objects and then chaining methods, so to speak. Okay, now you don't have to actually chain them like this if it's get confusing for you. You can assign them to variables. Let's say you can assign this whole thing to a variable, right? Let's say you assign that one to var1 is equal to this, right? Okay. So you know that it becomes a list, and then what do? You say var1 1 and then dot text. It's basically just the same thing. If you print this one now, okay, It's just the same thing, right? Um, but why do that, right? Um, like this is good if it's, you're just a beginner, you're not yet too used to programming or coding. If this helps you get less confusing, then that's okay. But you should practice to chain um, methods because it's a lot neater, it's more efficient, and it's easier to understand the more you look at it. All right. So, yeah. What's next? Okay. List has had two questions. Okay. Is this? Okay. This one is just list comprehension. Again, this is one of those things that is like a shortcut in um, it's like a shortcut in Python, right? Do you actually need this? No. Um, is it neater and easier to read? Yes. But, like I said before, if it's confusing, don't use it. So the equivalent for this one, right, that code is basically the same as us trying to have like list here, oh no, wait, blank is equals to a blank list, right? You have 4x in um, what loop? Soup.find.all. Okay, so soup.find underscore all, and then li, right? Okay, column. And then you would have access to each one, right? So you would say blank dot append, and then you would say x. I have access to each one, x dot text, right? And if I were to print blank again, yeah. So item 1, item 2, item 3. So this is the equivalent, right? If we were to manually code it for this, okay? It's called list comprehension, okay? So we just, um, since we know, right? Since we know that soup.find at all will return a list, we can just put it directly in a for loop and then loop over each item. That's what we did here. And then we know that each item, right, is each item is a beautiful soup object. That means we can do dot text after that automatically. And then we're gonna use the list method append to put the output here to that list, which resulted into this. Okay, basically the same as what's happening here. All right. So yeah. What if we have multiple lists? Yeah, okay, so now we're trying to use attributes, and this is how you would declare it, attributes, ATTRS. Okay, so, um, right, you would say, let's say the 12 variable this one, our list, all right. Let's imagine you have multiple ULs or unordered list, and you want to specifically choose this one, right? There are a lot of methods to do this. Okay, you can use a for find all and choose the first one if it's the first one, or you can be very accurate and go directly for the ID or the class list. Now, ID is a very safe bet. It's always unique. Developers in, it can, and it can be anything, web dev, game dev, any kind of dev. They or we usually reserve the ID parameter as unique. So you can be assured that what's the ID there is absolutely unique, right? But, if you were using other parameters or other attributes, then you can just declare the other things as well. Okay, so how do you do that? You would say soup dot find. So you would say attrs equals, and then open and close curly brace. Inside here, you would indicate class. I forgot if single quotes work. Let's try it. So class is equal to cool list. Cool list. All right. So just like a dictionary, you separate them like it was a dictionary. Okay. So key value pairs. Right. That's what we have here. Right. For the attributes, they look like key value pairs. So that's why it looks like this. Comma, and then ID. So then since we are naming them like this, they don't have to be in order, right? Remember, because we are calling them by name. ID must be list. So it must be a complete match for both ID and class in order for it to find that list. All right. And then okay. So after that, okay, I'm missing something. That one, and we can just print our list. Uh, yeah, we can just print that one. Then it should display this one. Let's add some more. Okay, just to be sure. Let's add more things to our HTML, and let's name this one list 2, list 3. What we're looking for is list 1, the very first one. Okay, so run, and as you can see, it got the correct one. Okay, even though it displayed it in different sequence, that's okay because they're just attributes. They can be interchanged in order, in their order, right? If we say list 2, but they have the same class, right? I'm going to run this code. What happened? Oh, okay, I forgot. There. None. Why? List 2. Who list none. Why is it displaying none? ID is list 2. List 2. Who list? Who list? Print our list. You mean if they not find it? Ah, okay, I forgot. I'm supposed to run this one first. Run this, then I'm gonna run this again. There you go. Okay. So whenever you are separating your code like this, make sure to run the previous one if you did any changes before running this the new cell. All right. Okay. What's next? Okay. What's this? Oh, okay, so it's an entire code. If you're viewing the PowerPoint, you can just click on the link. If you click on this link, this is just a text file for the code that whoever was making this, right, to be so that you can just copy it directly. Okay, but confirm it first, that it's correct before copying and pasting it. Just making sure that you're not actually copying something that's uh, you know invasive code. Right. So we have to be safe in this day and age with uh, the things that we are copying. All right. So complete code for this section. We can traverse the HTML using children, parent, and next. All right. So remember the concept we discussed earlier when we breezed over the topic of traversing the folders, right, in Python. So the same thing, we also name them children, parent, and then siblings, similar, okay? Descendant. It's still the same jargon, but we're in a different language. We're in the HTML now, but it basically works the same way. Okay, how children works. Children means that they are under or nesting on something else. This the parent is the one that the current thing that you're looking at is being nested to. Sibling is you are being nested together with, all right? And then descendants is children of your children. Makes sense, right? Descendant. The next here is a certain command in soup where you can just go to the next line and next line and next line of the HTML. So if you have um, this, right? So if you're here, go next, go next, go next. Okay, that's what basically it is. Okay, now, what's that one? Let's see here. Okay, so, uh, hold on guys, let me grab some water for a bit. Alright, so it's the last stretch, okay, the last 30 minutes before we are done. Oh yeah, by the way, I forgot. Today is our fifth session, right? So next week, I think someone else will take over, starting from session 6 up to session 10. Yeah, so it might be that someone else will use that extra hour that we missed before, remember? So it might be someone else that will use that 1 hour to um, to discuss more um, on data science. Okay, so now we're gonna try and scrape an actual web page. Okay, we have this link. Um, I'm gonna share it to you guys. So I looked at this one earlier and tried to see if it actually exists. So it does. List of countries by copy production. Alright, here. I'll send this one to everyone as well, the link. There you go, send to the group. Alright, so it should look something like this. This is the Wikipedia page for that list of countries by coffee production, right? So we choose this one because it's rather simple. It's an actual web page and there's not much restriction because this is Wikipedia. The entire page is loaded. There's no, right? This is as basic as you can get with a website, right? So this is what we call a static web page. Again, how do you know it's static? It's static because no new data is being requested whenever you're doing something. Okay, like this one I'm scrolling, right? It's not generating or requesting new data. If it was dynamic data, then it would be something like Facebook. If you scroll down, right, it would load new posts or feed, okay, in your page, right? So they do that to actually save data. So yeah. Um, right. So let's say our task is to go over here and then just get this data. We just need the production, the country and the production of each country of their coffee, right? Okay. Now you might be asking, sir, why not just copy and paste? Yeah, we could do that, but we're missing the point. It's not because the data is easy to get. We're we're just trying to simulate right now. Okay, this is the data that we're trying to get, but we can expand this one further later on. Like um, getting different products. If you're scraping products on sites like Amazon, Lazada, if you can, um, if you want to. So there are certain things that you have to watch out for, of course. Um, but yeah, let's go over that later. First is what you need to understand is that um, what the browser does is when you go to a page, right, it's gonna request certain files. One of those files is the HTML file, and from the HTML file, there will be commands there that will request other files. Makes sense? Because it's the skeleton of the web page, right? So, how do you see from the browser, right, what is being requested? So, they actually made it accessible to everyone. Okay, so all you need to do is press F12, I think. Yeah, F12. Okay, I thought I forgot to shoot that. Alright, so if you go to F12, or if you go to here, um, three dots, and then go to more tools, and then go to developer tools. This is what will come out. Okay, now there are a lot of tabs here, but the most important one is the elements. Now, when you click on the elements, it will show you the HTML page itself. Okay, that is important. When you go to network, it will show you blank. Why? Because you need to click on network and then the page should load in order for it to uh, see what's being requested from the server. So if I were to below this one and then have this in network, all right. So as you can see, these are all the files that are being downloaded or requested by you when you were accessing this website. Okay, so you can see the waterfall here. So it took around 1,500 milliseconds to load everything. Okay, and for each file, here is a um, estimation on the right as to how long it took. If you have visited this site before, that means there are certain things that are already saved in your memory cache. So if it's already in your memory cache, there's no need to re-download it and spend data. So it only spends data on the new things that it sees. So uh, this one, for example, this one, so it took 244 milliseconds to download this document, 85 for this one, as well as the size. As you can see, the size. Okay, so yeah, initiator is just where it came from, where the request came from. The type is just the type of file. The status is depending on the number here, it indicates the status of the request. So if it's um, what's this? If it's 200, I think it's yeah, 200 is all good. 304, I forgot what 304 means. Usually when I have this, I have a list on the right because there's a lot of status codes actually. Um, but yeah, okay, so for everything that you see here, from the images to the small icons, you can see it here actually. You can click one of those, like, let's look for something, an image. Let's go to type, web ping script, style sheet, fetch, script. Let's look for image. Okay, here's one. It's the Wikipedia icon, so ICO. So if you click on that one, it will show you more information about that file, the headers, right? If you click on preview, you can see what it looks like. If it was an image, it will show you the image here, so response, uh, right. So all these things are not actually necessary anymore, but it can help out a little in the long run when you get into more complex things. But for now, I want you to focus on elements. Usually these two are the things that you only need to look at. Elements and network. All the other things are for web developers. Alright? So, elements. Each one here, right? You can expand the head. Okay, you see this arrow. You can expand that one to see what's inside it. So, as you can see, there's a lot of here. There's a lot of things here. The metadata, links, the style sheets. Alright. You don't need to know what all the um, classes are for or what all the other attributes are for. Okay, that's not really our concern. Our concern is what to look for the data that we need. Okay, so we know that it's not going to be in the head for now. Sometimes some other information can be located in the head, but for now we know that it's not there. We know that it's in the body because you can see it on the page. Everything that you see on the page here is inside the body, so it's inside the body here, right? But you're not going to be doing it one by one, okay? Now the way that this works is it's very interactive, okay? If you go back here, okay? So let's say you want to look for where this one is located in the HTML code. You will need to press this, okay? So like an element in the page 2, inspect, or the inspect, and then click on it, and then put your mouse over the thing that you're looking for. So make sure you're highlighting the table itself. Or if not the table, then as close as you can get to it. Let's see. I'm gonna try it. No, I can't, right? Okay, so I guess I'll go to Brazil for now. Okay, so I don't know if you've noticed, but every time I change my highlight to something else, the code here at the bottom also changes, right? Like it's pointing me to where it is. So if I highlight this one, okay, it's also highlighted below in gray where the tag for that specific part of your page is. So it's in TD 341, 345, So TD is short for table data, right? Okay, so I'm gonna click on this one. Click so that it will stay there permanently. Now, all we need to do is just go back slowly. So we know that TD is nested. It's a child of something, so it's a child of TR. So TR is this entire row, see? So it goes both ways. If you highlight a certain tag here, it will also be highlighted on the page, see? So TR is this one, T body is this one. Okay, so this is actually what we're looking for, the T body, that's one. Alright, so we know where to look for. All our data is stored here. It's in what? Inside a table called this. There's actually no ID. But the thing about this is that if you examine the web page, there are no other tables that exist. So it's actually safe to assume that we can just look for the table directly. So we can have an access to this entire tag and everything in it. Okay, so let's do that, right? So okay, we know now what to do. We know where our data is located. Now we need to write the code, right? So first is you need the link. So copy this one, copy, go back to your code. Okay, there. Okay, you need to save it into a variable to make it easier later on to edit. All right. Page, right? you need to save into a variable the HTML that you will download here. Okay, so you're gonna say page, right? We're gonna use a certain library, by the way, and also I forgot our imports. So for now, I'm just gonna copy the imports that we have up here. Copy, copy, and then paste it here, as well as other things. So Beautiful Soup is for parsing and um, scraping data of the HTML, right? This one is for displaying it here in Jupyter Notebook. Now, what else do we need? We need also a library that will request a web page, right? Remember what I said earlier? These are the requests. When you enter a website at the address bar, you are requesting files for that web page. Okay, now we need to do the same in code. You need to request that one, so we need to use a certain library. Are there other libraries available? Yes, there is a lot, but in Python there is a default one you can use, so you can use that. Import, import requests with an S as RQ. Okay, now we'll use that one. So RQ dot get. So I won't go over get. Okay, I leave it up to you guys to search it on your own. But it's basically you just pass the URL there, and then um, it gives you the HTML. Okay, so get URL. It gives you the location, and then you just access the text property, so that you will get the uh, HTML. This one, okay. All right. So after that, we say soup is equals to bs, and then we pass in page. Now we are in the same stage as where we were at earlier. Okay. All right. So how do we know that it has loaded correctly? So you can just print that one. Soup, 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 soup. All right, and then enter. Wait for it. And there's an error. Okay. The input looks like a file name. You may want to open this file. A user agent. Okay, sorry. We're not printing a soup. That's an object. We need to print page. You may want to let's file. File handle to be possible. No, this is not a file. It should be saved in. Okay guys, give me a moment. It should be saved in page. URL button. RQ get text should also right as well as using here text soup bs page soup bs and then page uh it's just a warning, so it should all still display. It should still display the page. Okay, since the error is in here, let's try it that right now. Okay, set a user agent. Okay, we need to set the user agent. And is it stated here? No. Alright, so we need to do some few extra steps. Request, right, let's do a quick search. Request, input, user, agent. Request, library, I found input, user agent. How do we do that? So it should be, so here's a group one headers. You pass in the URL and the headers. Okay. Alright, so this is what we need. So we'll try and satisfy what it's asking for. Headers. I'm gonna try and make it the same as what I have here. So headers, let's see. User agent. So I'm gonna be using the same one as what I have here. So this is just click on anything and then go to headers, right? Header section, and then go to the request headers because you're trying to request something, right? And then go down and then user agent. Okay. So you guys have a lot of reading up to do. That's just how it goes in this line of work. Okay, I'll remove this one, change it to this. Oh, okay, it's just a different version at the end. Alright, that's okay. URL, and then, what was the format? You pass in the headers as well. Headers is equals to headers, okay. URL headers is equals to headers. There you go. Okay, now we have access to the HTML file and we were able to output it. There. We were able to output it here on the Jupyter notebook, right? We can see the HTML file. We can even confirm that if we want to by comparing it here, but that just takes time, right? So HTML, client.js, let's just look for that one if it exists here. So client Node.js, can I find it quickly? How about Node.js? Does it exist here? I think mine is Node.js because this is in Jupyter Notebook. So in here it says JS because it's in the web. In here it says Node.js because I don't have JavaScript here. It's Python. So that's okay. I think that's good enough for me. Here you go. So I think this is better. List of countries by coffee production, the title itself. So that is here. Title. Okay. So now we're sure that it's the same thing. Okay. So there's no need to print this one anymore. Next is we need it to be parsed by Python. So we pass it to Beautiful Soup. Alright. Now after passing it to Beautiful Soup, what do we do? Let's go to the next page. Okay, never mind that one. Okay, so this is how we scrape one web page, okay? Again, if you are able to scrape one web page, you can scrape multiple web page, alright? Understanding how to make this one work will, make it easier for you guys to do the next one and the next one because it's just the same concept. You're just adding extra layers depending on the type of web page that you're accessing to. Okay, if the data is in different pages, then all you have to do is make a list of all the links that you need and then access the link one by one. Okay, so you need to break down your step-by-step procedure, what you need to do. What I need to do is I need to get a list of all the links of all the products on this website. Then I need to access each product one by one using the request library, and then get the data of each product, save it to something, and then blah blah. So now you would have what? You would have a data set, right? You would have an Excel maybe, or I don't know, something, a text file, CSV, where all the data that you've collected is stored, ready for the next stage in data science, which is cleaning up the data and uh, creating the model. Okay. Okay, but that's still far off. Okay, let's focus on this one. So we need to scrape at least one web page for today. I think 15 minutes is enough because we just need to understand one concept. All right. All the other parts in this PowerPoint, you can do it by yourself. Okay, so we're looking for that table, right? I think we can just uh, list, loop, strip, split. Okay, so okay, so it should look something like this. We're just getting the top 10. All right. Uh, okay. Okay, there you go. We're looking for the table, so I'm gonna save it to a table variable. Um, we have access right to soup. We're gonna find, and then I'm fairly confident that it's saved in a table that's unique. So there's only one table, I think, on that page. Next is we need to have a variable for the top 10, right? So this is a list. Now, we have a table, right? And our here, right? And our elements here, Brazil. Okay, so we know that each one, the country and the production is stored in one row. Okay, so we can actually just look for the TR directly inside of the table. Okay, but there is a TR and the T head, right? We don't need this one. This is also stored in a TR. So we can skip the first occurrence of TR, right? Makes sense because this is the one that doesn't belong. We can just skip this one and go directly to the second one, right? Okay, so let's do that. We're creating a loop for row and table. That's a beautiful super table that find all. We're looking for the TR element, TR tag, and then we want to skip the first one, right? So this is a list. I want to get the second one, so that's index 1 up until we need top 10, so it should be plus 10, 11, right? So that's it. It should give me the 10 rows, the first 10 rows on that table. After that, we say temp is equals to row. It was temp, right? It's using temp, and then top 10. So my variables might be a little different, but it's still the same. Row dot row. Okay, so usually in these things, that's it. Okay, row dot text. let's print this one first. Okay, let's see what it looks like. Okay, so it looks just like this, alright? Um, hmm. Okay, so there are two spaces. We need to remove those two spaces. Okay, so that's why there was a replace there. So you can dot replace. Okay, why are we using dot replace? Because at this point, this is now a string. So automatically we can use string methods. Replace is one of the string methods. So you want to replace the slash n. If you remember, slash n is the enter key, right? Slash n slash n, since there are what is it? What's wrong with my keyboard? Dash. Okay guys, I'll just copy this one. It's getting annoying. My keyboard is not cooperating with me. So slash n, replace that one with blank, right? Okay, so if you do that, what would happen? It's not doing anything. Huh. Well, let's remove that one first. Let's try stripping immediately. What would happen? Okay. Strip. Alright. Okay, let's convert this one to a list. Temp of list is equals to temp dot split. Let's convert this and then try to see what it looks like. Okay, so now we have this one. It's not scrolling down. Okay, but it's in individual. It's still printed individually, right? But that's okay. We can just pass it later on to here. This is a bit tricky because it's Central African Republic. Right. We need to have an extra layer or step here to deal with this countries with which has two or more words. Let's skip that one for now. Let's just get the top 9 so that um, we can focus more on the concept. Okay, so strip, split. All we have to do now is to append this one to our top 10. So top 10 dot append, right? You would append your tab list. Okay, let's save this one as a tuple. I think it was making it into a tuple earlier. tuple, yes, it's making it a tuple. Temp list, accessing the first one. Yep, and then temp list, accessing the second one. Close, close. Alright, let me for this. Uh, Print top 10. It should be one list. List of tuples, okay. Alright, so now it's easier to see. Okay, we can access that one by one. Alright, so now we have all the data that we need, right? Okay, so this is still not the part where we are modifying the data. By the way, we're still retrieving the data, okay? So I know it's almost 5, guys. We'll just finish this one, right? Scraping one web page. Because after this, right, once you understand this part, this concept, all the other parts of this lesson is actually just the base. Okay, it's just basically rinse and repeat with a few extra steps. Okay. Um, Alright, what's the next? So what if we see display a graph, right? That's the next one. In this case, it's using Python as the library for creating a graph. Okay? Now, technically, at this point, we should not be using graphs, right? Because there's gonna be a different session in the future. I think session 8 and 9. They are more focused on graphs per se. So whatever types of graphs, the advantages of those graphs, which one should choose for a specific data type, right? But this is just a quick example. If you were to put it into a bar chart, you can use Python for that. There are a lot of libraries for creating graphs, but the most popular ones are Python, Seaboard, there's Matplotlib, right? But this is one of the most more user-friendly. It's the Python, okay? So, of course, you have to install this one, by the way, so you have to do it on your own. You guys know how to install it. But if you were to import it, then it should be something like this. So just as usual, import the library, Python, right? So as you can see, we're just basically repeating what we have learned before, right? Python, we're gonna use bar chart here. We haven't discussed this one yet, but this is as basic as we can get to create a basic bar chart. So if you were to read the documentation, this is how it should go. So you were to call Python dot bar. You were to indicate the height, at least the height of your bar, right? Okay, 400 sample, and then you were to see. Let's use list comprehension here so that you guys can also see how it looks like. So you say bar chart dot add. We're gonna add an item to the chart, and the item would be let's see. The item would be top 10, okay, so we're going to use item as the item 0 and item 1. Okay. I think that's it. And then for item 8, top 10. Top 10 is already in. list format, so that's good. Uh, close it. So this should give me the bar chart with all the things that it needs. Okay, basically I'm just adding it to the x-axis and the y-axis. That's what I'm doing here to the bar chart object that I used here. Then all you have to do is display it. So if you want to display it here, all you have to do is use the display command. You pass in the HTML, but for Pygol you need to um, let's see. If it's Pygol, you need to render. Yeah, bar chart dot render, and then you need to is Unicode. Yeah. True. So if you um, keep on programming, guys, keep on using the libraries, some of the properties will just, you know, um, you'll get to remember some of the properties or parameters automatically as you keep on using it. I think it should be good. If not, then it's perfectly okay as well to refer to a documentation. So I'm just not using it right now because it takes time. So I'm just using my stock knowledge, and right now it's not cooperating. Bar chart. Still not working. Less than is not supported. Instances of int and string. Why? Graph. It's here. The error occurred here. Why? It says less than not supported. Why is it not supported? So this is what is text format. I stripped it, I split it. It was a tuple, a list of tuples. All of them were strings. So this should work. What am I missing? What is it doing here? It's replacing int. Replacing comma with, oh, okay. Alright, so since this was a string, I see. Okay, so be careful with this one. I forgot, it was reading this one as a string, not as a number. So Pygol needs a number, not a string. So we need to convert it into a number. And before it can become a number, you uh, remove the comma. So you say replace, right? Inside the replace, you put the comma there with nothing. And then I think that's it. That's all it needs. Oh, wait, I forgot. It should be in an int. Int converted into a number. Alright, now as you can see, I have generated a graph inside of Jupyter Notebook. Okay, so the the bad thing about this is that if it's inside Jupyter Notebook, there's no JavaScript. JavaScript is another programming language. Okay, the great thing about Pygol is that if you were to use this one in JavaScript, right? If you go to the Pygel documentation, all right, this is what it should look like if it was displayed here as part of a web page. It would look something like this if it loads. All right, so here's another documentation, guys, that you need to read up on, right? So already there's how many things that you need to read up on. You need to read up on Beautiful Soup, Request, Pygel. You can skip this one, I think. Yeah. So already you have three more things to read. That should take you about a few months. I don't know. It depends on how much time you give to it every day. Right. If you were to view Pygel as a web page, it would be interactive like this one. See, if you put your mouse over here, you would have some kind of highlights, right? If you click on alpha, you will remove it from the display, something like that. Also for here, right? Alpha and beta, see, it's very interactive, especially if you're trying to present this information, right? So this is best, I think, if you were to put it on a website like this one. But if you were to import this one in something like Jupyter Notebook, it's gonna be static like this one. It's not gonna be interactive for security purposes, of course. Okay, but it's still, um, you know, it still satisfies the requirement of displaying the data in graph. Okay, so that's basically it, guys. The entire flow, okay, that we did is the same all throughout any kind of um, web scraping. Okay, the only thing that's different is that you need to insert some few extra steps here depending on the site that you're working on. So if you've noticed, if we skip a few pages here, so we have scraping multiple web page, the only difference here is that there's even as I said, there's even um, an algorithm here on what to do, a series of steps. Um, there's no pseudocode, but that's okay. There's also sample text, but the difference here, the main difference is this one. We're looking at books this time. So the only difference here is this. You extract each book from the list and get the weak link of each book, right? So imagine you have thousands of books. You get the link of each book stored in the a tag href attribute. Okay, then so you have a list, right? You would have a list of all the links. So all you have to do after that is do the same thing as this one. You pass the URL or the link, right, to our queue, and then do the same thing. Access the data that you need, right? Look for the data that you need and then save it somewhere. So basically this whole thing will be in a loop. You put this one into a loop and then put additional code here that will extract the all the links from that page. That's basically it. And then from then on, you try and go up, challenge yourself a little bit. Go to the next one, like go for sites like Amazon. Look for the limits of what you can scrape, right? The only thing that I do want you to remember is that if you're scraping something, right? The only thing that you need to remember, just to be safe, is if okay, avoid data with intellectual property. Okay, so what I mean is, um, like research papers or I think art can also be included in that. So unless you have, um, I think you can scrape the ones with, um, how do I say this, with watermarks. I think, yeah. So a quick Google search and a confirmation from the site. You know, there should be uh, something there that tells you if you're allowed to scrape. But you know, avoid data with intellectual property. And if if it was public, right? It is free to scrape. So what do I mean by this? This is where tweets come in. This is where post comes in. That you are posting in public. You are tagging it as public. That means it is free for anyone to get. Um, but you have to be careful still. You know. So that's why, like, you must be wondering why there are some free apps like Facebook is free registration. It's because, like what they say, we are the product of those applications, right? Um, okay, so what else? Okay, yeah, you need to also visit robots.text. So depending on the developer, they almost always put this one, especially for websites that are, you know, um, already, it's already like established. That's what I mean. So if you go to the main page, something like this, go to the base URL. So that would be under work, and then you put robots.text here. This can be for any site, okay, not just Wikipedia. You will get to a file like this, okay? Now this file is a declaration of what they allow and what they don't allow, okay? So there are pages here where they say that you cannot scrape or you're not access and so on and so forth. So this is a good resource as well as to how you can know if you're allowed to scrape or not. All right, so if you go to Yahoo, for example, Yahoo Finance maybe, because scrapers are always visiting the site because it's a stock market. This one, close this, close this. Okay, this is the last one, guys. Alright, so Yahoo Finance, just remove this one, go to the base URL, and then robots.txt, just to show you guys that this exists. And it's not loading. Okay, you have to stop it. Robots.txt. Okay, there you go. All right. What else? I think that's everything. Let's see. Okay. Right. So I think that's all. What else? Oh, the rate of access. So whenever you're trying to access data using scrapers, um, it should be listed somewhere here, but they should say like scrapers should access data like um, one request per second. So you need to add a timer in your code that will request the next book, in this case, in this one, that will request the next book after 1 second, or depending on the site that um, you're looking for, right? Again, a quick Google search. Somebody should have done that by now, so they know what is and is not allowed. So yeah. All right. That's all for now. Um, yeah. I guess that's it. So see you guys. Oh no, wait. It's gonna be someone else next week. All right. So that's it for me. Have a great weekend. Goodbye. Thank you.